Alright, so I know that we've been working with the unit circle and we have been able to fill out the values for degrees and then for radians, right? And then you guys are asking about these coordinate points and what do they represent. So we're going to go over that in this video, okay? So before we start, I want you to go ahead and fill out what you know. So for example, this one will be 30 degrees, this one will be 45 degrees, and then this one will be 60 degrees. Okay? Now in radians, this would be pi over 6, right? This one would be pi over 4, and then this one will be pi over 3. Okay? Now we're going to just go ahead and focus on the 30 degree, and then we'll worry about 45 and 60. So I'm just going to walk you through the 30 degree. We'll be able to fill this out. Okay? Alright, so what I want you to do is get your straight edge. I'm going to use my ruler here, and I want you to draw a line from our point perpendicular to the x-axis. So we're going to draw it here, okay? And then we know that this will be 90 degrees. Alright, so the angle that we are focusing on is this one here, and we said it's going to be 30 degrees, or again pi over 6. Either one is fine. Okay? Now because this is the unit circle, then what is the radius? The radius is 1. Again, why? Because it's the unit circle. Okay, and then the triangle that I want you to focus on, okay, so you could see it better, I'm going to just highlight it. So it's this side, and then this side. Okay? So we're just going to focus on that triangle right there. Alright, now we know one side already, and that is this side. Okay? Now if you compare this side in relation to this angle, then what would you say? Would you say this is the opposite side to this angle? Would you say this is the adjacent side? Or would you say this is the hypotenuse to this side, to this angle? Okay, if you are saying that it is the hypotenuse, you are correct. This is the hypotenuse. Again, in relation to this angle. Now what about this side? What is the relationship between this side and this angle? I'm giving you some time to think about it. If you are saying the adjacent, then you are correct. This is the adjacent side to this angle because it's connected to the angle. Okay, and then obviously this one on this other side would be what? It would be the opposite side. Right? So here we go. We have the opposite, we have the adjacent, and now we have the hypotenuse. Okay? Now, knowing this here, we could find this side and this side by realizing a few things. First of all, if this is 30 degrees and this is 90, and remember, all interior angles of a triangle have to add up to what? 180, right? 180 degrees. So therefore, what's 90 plus 30? 90 plus 30, that's 120, right? So 120 degrees. What is needed so that they all add up to 180? Well, let's see, 120. How much more do we need? 60, right? 60 plus 120, that gives us the 180. So this has to be 60 degrees. Okay, so now you're thinking back to geometry. 30, 60, 90. we remember the ratios, right? It's a unit times square root of 3 and then double this unit. Now if you don't remember that, that's fine. I mean, I can show you how we deduce it. If you would extend this, right, this triangle, if you would extend this side of the triangle all the way over here, then you will notice that we have an equilateral triangle. We have 60 degrees, 30, this would also be 30, right? And then this would be 60 degrees. And obviously this is also 90. So now the triangle that I'm talking about is this one here, from here to here to here to here. If you notice, it's equilateral, 60 degrees, 60 degrees, 60 degrees. And what do we know about equilateral triangles? All sides should have the same length. So if this is 1, this is 1, and that makes sense because look, radius of the circle, same circle. Okay? If this angle is, right, 30 degrees is half of your 60, right, that means that this highlighted portion of this whole side of your equilateral triangle would be half the distance or half the length of this entire side. And like we said, if this is 1, and if this is 1, and if this is 1, then what would this be? Well, if you're thinking, well, it'll be half of this, correct. And what's half of 1? Well, it's just a half. So that length is 1/2. Right? So you have 1/2, and then you have 1. So let me highlight that so you could see it better. Okay, so you have half here, 1 here. Now we're just missing this side. And for that, we could use the Pythagorean Theorem. Right? This side length squared plus this side length squared equals to this side length squared. Okay, so we're going to do this on a separate page, okay? Okay, so here's my other sheet. I'm just going to use this sheet so that I have more space. But let's do the Pythagorean Theorem and let's figure this side out, right? I have no idea what that is. So here we go. It's going to be this side length squared, right? Plus this side length, I'll just call it B, is equal to the hypotenuse squared, right? Which is 1 squared. Okay? Now it's just a matter of solving this, and let's see what we get for the value of B. Okay, so 1 squared, that gives you 1. 2 squared gives you what? 4. Plus, we got our variable here. And then 1 squared, that's just 1. Okay? Alright, so remember, this is our equal sign. If we subtract 1/4, right, we got to get our variable alone. We got to isolate it. This is gone now, so we have b squared equals to 1 take away 1/4. Okay? Now we should know that in order for us to subtract these, we need to have the same denominator. And I always tell you guys, let's disguise the 1 as 4 divided by 4. Okay? Now I didn't do any trickery here. 4 divided by 4 is 1, and this is 1, so we actually didn't change the value of anything here. We're just disguising 1 as 4/4 so that we could subtract these, right? So I get b squared is equal to, what's 4 take away 1? That's 3. Remember to keep the denominator. So now we have b squared is equal to 3/4 we got to take the square root on both sides now to get rid of the square. So I'm going to follow along over here. So I'm going to say b now is equal to, right, because the square root of b squared is b, is equal to, now obviously it would be plus or minus, but because we're dealing with length here, right, we're just going to deal with the positive. So we're going to say square root of 3 over the square root of 4. Right? So we're going to say b is equal to, what's the square root of 3? We're going to leave that alone there. We don't have a calculator with us. But what's the square root of 4? Oh, that one we could do. We could say that's 2. So there we have it. We have radical 3 over 2. So this is actually radical 3 over 2. I'm going to highlight that. So now we have our 3 side lengths. We have radical 3 over 2, we have 1/2, and we have 1. And again, we did that using the Pythagorean Theorem. Okay, so let me come back to this here. And now you could say, oh, this is radical 3 over 2. Right? And again, you should know how we got radical 3 over 2 now. And now we could continue. Okay, why did I need all 3 sides to begin with? Well, think of any coordinate on the xy plane. For this coordinate, right, you start at the origin, you go some distance to the right, and then you go some distance up. For this coordinate, we're going again some distance to the right and then some distance up. That's going to give us this coordinate. Well, now that we found the 3 lengths of our sides of the triangle, we know exactly what that length is. What's the length from here to here? It's this, right? So guess what? The coordinate point, the x component, is radical 3 over 2, because we went this way, radical 3 over 2. Now, what length did we go up? You're probably saying 1/2. You're absolutely right. We went up 1/2 length, so this is 1/2. Okay? Now, why is this such a big deal? Because think back to SOHCAHTOA. Think back to SOHCAHTOA. What is sine defined as? What's the O? Opposite over H is what? Hypotenuse. So the sine of your angle is equal to opposite over hypotenuse. Now, if you're thinking, okay, what about that? Well, what is the opposite over hypotenuse? What's 1/2 over 1? Well, 1/2 divided by 1, that's just a 1/2. That's this value. So therefore, what is the y component of 30 degrees? It's 1/2. Isn't that the same as saying the sine of our angle, which is 30 degrees? Right? What's the opposite? That's a 1/2. Right? A 1/2 divided by 1. Well, that's just sine of 30 is equal to 1/2. Right? 1/2 divided by 1 is just 1/2. So therefore, what is this equivalent to? A 1/2 is the same as your sine value at this angle. So what do you think radical 3 over 2 represents? Let's see, radical 3 over 2, that's adjacent over what? Hypotenuse. Adjacent over hypotenuse. Oh, this means this is cosine. cosine value of 30 degrees is radical 3 over 2. So then that means that for each component, right, for x, this is cosine at your angle. This is going to be the value of cosine of 60. This is going to be the value of cosine at 45. This one will be what? Sine of what? 45. Very good. Sine of 45. This will be sine of 60. Okay? So now, I walked you through the process of coming up with the components for 30 degrees. Now I want you to go ahead and do the components for 45 degrees, or pi over 4, and I want you to come up with the components for 60 degrees, or pi over 3. Okay, and to get you started with that, you're probably thinking, well, what do I do? Do the same thing. Come up with your triangle, and now instead of 30, this is going to be what? This is going to be 45. 45, 45, 90. And then for this one, you're going to draw this, and then go ahead and use, same thing, we're going to set the triangle up on a separate sheet of paper. I want you to draw it, use Pythagorean Theorem, and then write down each of the x component and y component for your triangle, and then come up with your coordinate points for this and this. Okay? You're probably thinking, what is this and what is this? Well, this would be 1, 0, because that's the length of the radius. You're not going up or down, so that's 0. And what is this? This is going to be what? 0, up 1 unit, because that's your radius. Okay? Once you have your components for the first quadrant, everything else is going to be simple. And I'll show you how to do that in the next video. Alright? Okay. Good luck.